Hello, everyone. My name's Andy. I'm a software engineer at Zalando in Berlin, mostly focusing on Android. And for those of you that aren't familiar with Zalando, we sell clothes and shoes and beauty products throughout Europe in 17 different countries. For those of you from the US or familiar with Zappos, it's similar idea. So I'm here today to tell you a bit about what we've been building for the last several months and what we've learned along the way. So start with an outline. So I'll talk a bit about the problem itself and why we decided to build what we built, and then talk a bit about the solution and how we put all this together. And since this is a mobile conference, to dig more into the mobile client side of things primarily. Then follow that with a demo showing like how all these pieces fit together, and then finally talk a bit about like future plans and some of the lessons we learned along the way. So what is the problem? Here you see kind of your traditional mobile app architecture. On the right you have cloud microservices, and usually there's a bunch of those, and you need some kind of gateway to serve all that to the mobile apps in a clean way so they don't have to go to multiple services to get their data. And then we have this white line, which is kind of the boundary between this client and server. And then over on the left you have kind of these boxes that we all know. You make a networking request, it's not in the shape you need it, so you have to transform it. Then you have your view model or presenter, whatever it may be, because we want clean code and slim activities or fragments, and then the fragment and the UI. And on Android, this is XML still, starting to change. But you see the dotted box around that. This is like every screen. So every screen has to make some network requests, has to do some transformation, has a layout. Sometimes you can design your app in a way that these are shared in a smart way, but the fact is every screen is different and requires some code unique to that screen in some way. And then on top of this, you have iOS and Android, so like this has to be done basically twice every time there's a change. So I mentioned every time there's a change, like what really happens behind the scenes when the product owner comes and says, we want to change the color of this button. Always, there's some kind of meeting, whether it's a short conversation or a grooming meeting, sprint planning, that kind of thing. And then you have to have tickets, right? Jira, probably. Who uses Jira? Everybody? Anything else? We should talk. I'm curious what else there is. Kidding. So yeah, you have your one or more tickets, and then you finally get to write code. I think this is why most of us are in this profession, right? The one little bit here is the code that we like. And then if you're writing code, of course you have to write tests. It's debatable if the test comes before the code. Sometimes it does. And once you're done verifying all your changes, you have to open the PR. And as we all know, it's not just open the PR and it gets merged. Like there's discussion, people have opinions, like why don't you try this, why don't you try that? Eventually everybody's in some sort of agreement or at least compromise, and then you finally merge the PR. And then you do regression testing and QA. And yeah, another interesting thing about Zalando, that I never worked anywhere like this, but we don't have QA. We are our own QA. And if you think about that for a minute, if you had to go and tap through the app every time before you did a release, what would you do? Automate it, right? Because we're lazy. So it kind of forces us to write tests because our interests are aligned with, shipping quality. We're not throwing it over the wall to QA. So anyway, this is kind of the process you go through for every single change. There's the app release. So finally, you do your app release after all of this. But there should be like a better way to like speed this up, right? So I mentioned in the talk description that you can use React Native and CodePush to do this. But one downside of this is you have to write any of the logic that you want to dynamically update in JavaScript. And it's kind of a gray area. Both Apple and Google haven't said you can't do this, but they also haven't said you can. So anyway, we tried it, and as many people have kind of said the same thing, like this integration, cross-platform tools with existing apps is quite hard. You could build like a new app from scratch with something like React Native or Flutter, and it's going to work pretty well for you. But the integration and the bridging and all of this, that's where we spent most of our time. And if you haven't read Gabriel Peel's 5-post series from Airbnb, I highly recommend that. Our experience was very similar to theirs, just on a smaller scale. So we weren't really satisfied with just going back to building everything twice on both platforms. So we assembled a small team and started experimenting with server-driven UI, and this is like discussed in the fifth and final part of that Airbnb series. And I swear it's completely a coincidence. We didn't just like do the same thing. We didn't even know it was called server-driven UI until we read their post, like, oh, that's what the name of this is. So anyway, going back a little, our experience with server-driven UI dates back a few years. This is the home screen of our app. And you can see there's a lot of rich content here, images, text, carousels. And this is, it's server-driven. The content's personalized based on the customer's country, previous purchases, favorite brands, and so on. But it's not entirely dynamic. The data comes from the server, and the layout structure comes from the server, but the apps themselves have code that renders that image with the text on it, and this carousel with the title and the call to action button at the top. So it's kind of dynamic. But you still have to, if you want to change some of that behavior, you still have to do an app release, so it doesn't completely solve the problem. So we thought about this for a while, and if you look at the way an app is built, like you have some text, you have some images, they have to be laid out in some way. But if you can think of terms in terms of those primitives and then define some sort of platform-independent layout system that you could build the screens with, it could be possible to do the entire thing dynamically. And then if you take it a step further, like to solve the problem of different API responses for different screens, we started thinking, like, what if there was a way that you could define the layout and the data for every screen in the exact same way, like regardless of the data source? So sounds like just kind of a pipe dream that's like something that's like impossible, but we tried. So here's the diagram of what we call AppCraft. As you might have guessed, it's a Minecraft-inspired naming scheme. You'll see that, or well, actually you see that over here on the right with the names of these services. I will go into more detail about what each of those are in a minute, but the important difference to notice is there's not an API gateway here. There's a whole bunch of, or there's like these 3 services, Beetroot, Furnace, and Compass. And then on the app side, we still have the networking code, and we still do some transformation. I'll explain why when we get to that point. But then these 2 boxes on the right are a bit different. We have a Redux store, which is storing the data that we need to show on the screen, and then we have some UI rendering code that renders it. So there's this, in the Android context, there's like a single fragment that is capable of rendering every screen we build with this tool. So let me talk a bit more about those boxes on the right there. So the first service we have is called Compass, and its purpose is, instead of us building all of our screens in our IDE, like we wanted to enable, like, ideally non-technical people, but initially, like, you have to have some technical knowledge to do this. But we wanted to build like a web-based screen editor where basically people can just drag and drop UI elements and a data source and do some manipulation on that data, and that would be kind of the mechanism for building screens. And this has to be done in a platform-independent way, because if they have to build it twice, it's not really solving the problem. So after the screen is built in Compass with the data and the UI, the output of that is just a series of links and nodes, like exactly like a Google interview question. And that's passed to that's passed to this service called Furnace here on the left. And Furnace's job is to take those series of links and nodes and dynamically generate the GraphQL query that those are based on. So the data source I mentioned is GraphQL. The binding process I mentioned is kind of drilling down in that GraphQL data source to the fields you want. And then with that information, we can dynamically generate the GraphQL query for any screen. So Furnace stores that, manages versions, and all of this important stuff. And then we go to Beetroot. So Beetroot is the service that the apps talk to. And Beetroot's job is to execute that GraphQL query and then transform the data and the layout and data into an API response that the apps are expecting. So if you think about those two diagrams, there's only small changes between them. But with these small changes, we have several things that apps don't have to care about at all anymore. Layout, for example, if it's phone or tablet, if it's different countries, if there's an A/B test happening, like we just pass headers to the server to give it the information it needs, and it decides like what our layout looks like. Localization, like we don't care about we wouldn't have to care about translations in the app anymore because the server is going to see their country and language preference and give us the text in the appropriate language. And then tracking and analytics. I think we've all gone through our app and sprinkled all the tracking code in there and grumbled every time an analyst came and asked us to add more tracking. So yeah, pushing all that to the server was another nice thing about this approach. But yeah, what's interesting here is like everything in this list, this is the reason your app has to change. This is the reason you have to go through all those steps I mentioned and do app releases. So yeah, with all this moved to the server, like the app is basically just responsible for rendering the UI and responding to user input. So there's a lot of really interesting technical details going on the server, and I did my best to kind of explain them without going super deep, but since this is a mobile conference, I'll move on to the mobile side. So keeping with the Minecraft theme, we named the Android library Golem. Based on my limited knowledge of Minecraft, that's like the closest thing to a robot I could find. And then Lapis, I guess because iOS devices are precious gems, that's a suitable name. So yeah, as I mentioned, I'm an Android developer, so I'll focus primarily on Android, but I'll do my best to mention the iOS equivalents in our architecture along the way. So let's start by looking at the API endpoints that our libraries have to use. So I mentioned instead of fetching the data from a bunch of different endpoints, there's far fewer, and currently with AppCraft we have 4. So these are configuration, which is exactly what you'd expect, a lot of stuff related to tracking and so on that we fetch on app startup so we know what events to send and things like that. The layout response, or layout endpoint that I mentioned. And this is separated from the data, which is the third, because if you know the layout ahead of time, you can show placeholders very easily. You just make gray boxes everywhere instead of the actual content. So we knew that the data and the dynamically generated query and so on was going to be one of our things that we would need to speed up. So yeah, having the layout and data separate also allows us to cache the layout for certain screens. So yeah, that was kind of a optimization decision. And then finally, component data. So if you have like a list of data and it's paginated, you need to fetch data for a specific component at some point. So yeah, this is basically how it all works. And a key part of this was the initiative we had like separately to move all of our data to GraphQL. I don't think if we didn't have GraphQL, it would be really hard to do this dynamic query generation and operate with so few endpoints. So what are these, maybe the configuration and configuration endpoint's not so interesting, but the layout response, I'll show an example here of just a sample of how this would look. So every layout response has some sort of screen ID. That's the screen we're requesting the layout for, and it has a root component. And in there, there's some sort of ID. There's a type, which in this case, the root layout's the layout, and it may have children, which in the case of a layout is the case. So yeah, children, which is just an array of more components. So here's a component called hello text. It's a text type. And then we have polymorphic responses here. So there's the text. And you see here's placeholder text. So we get a layout response and a data response. And it's possible to have like some placeholders or other types of stuff that comes in a layout and then gets replaced with the data. So you can handle like loading states and stuff pretty easily. And then below that, we have like all the things you would need if you're rendering a layout. So styles, which are component dependent, or depends on the type of component, and then various events like tap and I guess tap and scroll and some things like that. And then inside the events, there's also actions. So a tap event could trigger launching a deep link or some tracking. So it's the general structure. And as you see here, it's basically an HTML hierarchy. And similarly, here's the data response. Its structure mirrors the layout response. So on the client, we just put these two together and render the result. So yeah, basically the same. We have a root component, and instead of children, it's called items. And in there, we get the actual data. So this would be the result of running whatever query. In this case, it's static text, but yeah, you get the idea. So hello, Mobius conference. OK, so speaking of rendering, now we can move to the UI. And I mentioned the need for a platform-independent layout solution. The reason for this is on Android, the recommended approach for writing new layouts is constraint layout, and on iOS, you have auto layout. And neither of these are well suited to being created programmatically in a platform-independent way. You can definitely do like a constraint layout programmatically, but it is difficult to code. And yeah, doing the same for auto layout and keeping those consistent, that wasn't something we wanted to do. So we also needed a way to absolutely position certain things, like you might have seen in the home screen GIF I showed that we have a wishlist button on top of an image. And so on Android, you could use a frame layout and stack that, or with constraint layout, of course, there's ways to do that. Having worked with React Native, we got exposed to the Flexbox Layout system, and we thought, yeah, the Flexbox is a good way of describing a layout in a platform-independent way. So we looked at, or at least on the Android side, looked at Google's Flexbox implementation. It's probably a couple of years old. I don't think it's been updated in a while, and it didn't support absolute positioning. So then that led us to Litho on the Android side. And if you're not familiar with that, that's Facebook's UI library for their immutable views, and it's async, it does view flattening, like a lot of really cool features. We came to it just specifically for the Flexbox needs, but it ended up having a big role in our architecture, which I can show here in a little bit. And then on the iOS side, we used texture from Pinterest. It's similar in a lot of ways. So I will focus here on Litho. I'm told texture works in a similar way. So here's an example of like building a component in Litho. You have this annotation here called layout spec, which is just an indication to Litho that this is a component that it needs to run some annotation processing on during your build. And by convention, you name your component like something component and spec. I'll show you why in a minute. And then you have this onCreate layout annotation. There's many of them. If you're familiar with React, a lot of these annotations are like similar to the React lifecycle methods. So in create layout, you're going to get this component context, which is Litho's wrapper around the Android context. They have some additional data that they include in there. So then you actually build your component. So in this case, we're just making a simple text component using Litho's built-in text component, setting some text and a size and calling build on it. And we'll see in a minute what this results in. But before I do that, this is for creating like a pure Litho component using other Litho components inside. You also have the ability to bring in native views. And if you have an existing app and you want to use something like Litho, this is very handy. So it's a similar process, but you have a mount spec annotation. So this is basically telling Litho we're going to mount some sort of native view or drawable. And there's typically at least two functions you're going to implement for this. The first one is on create mount content, and this is just going to inflate your view or drawable and return it. And then on mount receives, again, a component context and the view or drawable you created in the mount content method. And then you have this prop annotation here, again, with the React similarities. So props are basically values that get passed into your components. And this annotation, we'll see in a minute, causes Litho to give you a setter for this property. So then in this case, we just parse our color and assign it to the drawable. So putting it all together, this could be anywhere in your code. I just made a function called createView that's going to return a Litho view. So the first thing you do is you create this component context, which takes the Android context. And this is important. Every component in your tree needs to be created with the same context. It's one of the mechanisms Litho uses to determine what's changed when it does the diffing. Notice here we don't have that spec annotation anymore. It just created, after we build our code, those annotated classes we have get turned into code like this. So you call Litho component create, set background. Background is an attribute on text, and then we here can use the color component we also created, so it's composable, things like React and Flutter, Jetpack Compose. And finally, you create a Litho view and you give it your component and you can return it. Typically in your code, you'd probably have a render method that returns the component, and you'd have a reference to the Litho view, and you'd just update the component on the view. So this is a little different for example purposes, but if you have a single Litho component instance and you assign the component over and over, it is going to diff it and only render what's changed. So if you saw Hannes and Konstantin's talk earlier, they were talking about a similar pattern of just rendering from state. And Litho is set up exactly for this. It's very efficient at doing this. And yeah, you're no longer getting references to views and updating them individually. You're just like, here's your component tree, diff it, show it. So works pretty well. So moving back to AppCraft and how we're using all this, also texture, we had to define these like a set of UI primitives or just basic components that we would build most of our UIs out of. So yeah, I already mentioned text, button, and image. Kind of the obvious things, and then you're going to need some sort of container for those views. So we have layouts, vertical, horizontal. This is an interesting, recent development. So we originally had a list as its own component, and you could bind data to it. But then when we needed to do heterogeneous lists, things got really complicated. So we thought about, well, if the layout has a scrollable property and you can put things in it, and you have something called a repeater that you can also put in there, you're kind of implicitly defining a recycler view. It's like a heterogeneous recycler view. And Litho is great at this. I have a nice wrapper around the recycler view. So yeah, a repeater is basically just a component that repeats its children. And then you can easily build things like parallax layout, which is just a layout that takes two root components. One's the header and one's the footer, and yeah. So it's all components all the way down. And in a few cases, we had certain app-specific behavior that was like a little too complicated to build out of these primitives. It might need some data from we call it the main app. So we have the AppCraft stuff and then like the main app, which is all the existing code. So things like which items are in a user's wish list, that's cached. We need to pull that into our Redux store so we can use it in our UI rendering. And then there's like special behaviors in there, like is it in the wish list, is it not? Same thing with the cart and follow button. So these are like multi-state buttons, and we have plans to eventually build this into our platform, but it was easier to just wrap them as like standalone things initially. And then finally, like a price component that might have an original price with strike through and a different color and discounted price. And that was just a little complex to describe in this UI editor that I'll show shortly. So we also made some dedicated components for that. So yeah, I mentioned Redux briefly earlier. This is another thing that we came to love from our experiments with React Native. So for those of you that aren't familiar with it, like the general concept is just a unidirectional data flow, and it's similar to model view intent or various other patterns you might have heard of. But in this pattern, you basically have a component or a UI view that observes a state store of some kind, and then you dispatch actions. Those actions change the state, and then that triggers a re-render, and this loop just continues indefinitely. So on Android, there's a few libraries that do this, so you don't really have to build your own. First is RxRedux from Freeletics, and then we have Mobius, the library, not the conference, from Spotify, and then Mavericks from Airbnb. Some of these are more opinionated than others, but yeah, they're all like a state store of some kind that your UI can observe and render when things change. So now we've seen kind of all the pieces that we're using on the mobile client side. So now I'll talk a bit about how we're actually, how they fit together to dynamically render a screen. So first is the layout request I mentioned. That's when we fetch the layout and render some placeholders. Or default values, which is step 2 there. And as soon as we get the layout request, we're also firing the data request to get the actual data. And then that data gets added to our Redux store, triggers another re-render with the layout bound with the data and events. And at this point, the user can interact with the app just like normal. And I mentioned the paginated requests, so if we need to get additional data, then we'll fetch that as like when the user scrolls to the bottom of the screen or something like that. So yeah, I mentioned Litho's optimized to diff the changes. So yeah, it's that Redux style loop that I showed just over and over. And with that, it's really easy to make I don't have an example, but if you imagine a whole bunch of wishlist buttons and then an add all to wishlist button, and if you tap all of those and put them in your wishlist, then the button at the bottom should change its text to remove all from wishlist. And so when you have this like relationship between views, if you're just rendering from a state, it's really easy to have them be in sync. So here's a diagram of the Android architecture, and it's similar on iOS. We have an API layer at the bottom, which is retrofit, surprise, and some amount of transformation. Most of this is because we have like data I mentioned, like the wishlist cache that's coming from the existing app, and we need to combine that with the stuff that we're fetching from our server. So we do a little bit of transformation. This ends up in the Redux store. And then we're using the view model from the architecture components. So we have just a single view model called screen view model, and that is responsible for observing this Redux store and creating the component tree. Well, not creating the component tree. The view factory next to it is actually the one that creates the component tree. And the screen view model emits that to the fragment, which in turn just sticks it in that litho view we talked about. So I'm sure some of you have already thought like, oh yeah, doing all this completely dynamically sounds really cool, but like, how is that going to work in practice? Like, if everything's dynamic, how do you know what's happening? So obviously, we have to spend some time thinking about and talking about testing. So we're building a library, and I guess the decision for that was just it allows us to iterate quicker. We have a small, lightweight app that we can develop in, and then we issue a build to our internal Maven repo, and then that gets pulled into the main app. So building a library, we needed, well, I guess regardless of whether you're building a library, like static analysis is good. But yeah, code styles to avoid the arguments and pull requests, lint also, public API, this is the thing I was getting at with the library. So we also have a public API check, so if we are exposing some members in a class or a class itself that should have been internal, and that changes, we will fail the build because we notice that something changed in the public API. So if you're building a library, it's very handy to do that. And then, of course, unit tests, whether it's at the bottom of the pyramid or the stem of the mushroom, whichever architecture you prefer there, definitely have to have your unit tests. And using a Redux architecture makes it really easy to test a lot of things because as Hannes and Konstantin mentioned, they're pure functions. So your reducer, you pass in a state and an action, and it gives you a new state. So if all of your state changes are happening in a single place, testing them becomes really easy. But we're building a UI library here, so of course we also need to have some UI tests. So for our purposes, screenshot tests are really nice. If you have screenshot tests and something like Firebase Test Lab, you can run all kinds of tests on all kinds of devices, and it makes it really easy to validate that things are working the way you expect. And then, of course, since we're depending on the server for so much dynamic content, we also have to have some end-to-end integration tests, so we know if a deploy from one of the microservices breaks the client, like we need to know that before it ever ships. So all of this is kind of working together to make sure that we're building what we intend. And then one of our teams built a project called TestCraft that actually makes this even easier. So you can see from the different text here that we have various combinations. So we have a footnote text style and unlimited. I don't know what the unlimited means in this case. Actually, sorry, the point is there's various combinations, and we can put these combinations into a YAML file, and then it will generate a class that we can implement the actual screenshot taking and a UI model to pass into that. So this is the output of our screenshot tests that run as part of our build, and yeah, if the test or if the screenshot on the right doesn't match the one on the left, then you get an error and your build fails. So I will now show a demo of just kind of tying all this together. First, I'll start with building a small component, which is a collection of other components that you can then use in a screen. But to avoid all of the things that could go wrong with a live demo at a conference, I'm just going to show a video and talk. So let's do that. So first I'll show building a component, a reusable component that we might want to use on multiple screens. So in this case, it's an outfit card. And this is going to show some outfit that was created by an influencer and allow you to see or add all the items in that outfit to your wish list if you are so inclined. So over here on the right, we have a list of components and data sources, and we drag and drop an image on there. And on the left here, we have inlets, so we can give names to attributes we might want to bind to data. So we're going to name this outfit image URL. And then we'll search for a layout component, which is going to contain some text views. We go in to edit that, and we can search for also the influencer image, but it needs to be round, and it needs to be smaller. So we put those there, and we give that an influencer image URL inlet. And then we're going to drop another layout because we need two text views that are on top of each other. So we'll have a vertical layout, and we'll drop a couple text views in here. And set the inlet there for the influencer name, and then the item count. Okay, and now we need to make that layout horizontal, not that layout, the other one. Yeah, make that layout horizontal. And now we can save this, and the wishlist button. Okay, yeah, and that has to be absolutely positioned, so we have these nice little arrows to put it up there, and that wishlist button needs to be bound to the SKUs, which is a retail acronym for stock keeping units. So that wishlist button is bound to a list of SKUs, and when you tap it, those are the SKUs that are going to be put in your wishlist. So I'm going to switch to QuickTime here because this video is a little fast, and I'm going to want to pause it as I talk through it. So now we'll see using that outfit card component we built and actually putting it into a screen. So in reality, we would probably give these more meaningful names, but we give the screen a name and an ID. And I'll pause this here so you can see over on the right, the greenish colored blocks are data sources. The blue ones, like the button component there, are components, UI views. And then these FX you see here are functions. So what we're going to see here is dragging and dropping views onto the screen and data sources, and then using functions to connect them. So bear with me. This goes pretty fast, and I'm going to try to pause it as it goes. So first, we put a list component on the screen. This is the homogeneous list component I mentioned that we're starting to move away from, but for now, it does work for a single collection of items. So when we drop this component here, we get this list, and there's some attributes for like pagination and a tap event handler, and this is also related to pagination. So then next, this is the outfit component we created previously, so we're going to drag and drop that in there, and you see the preview. It's very similar to what we already saw, and you can see down here that it's starting to show the top of the next image, so it's in a list now. So there we go. Okay. I'll keep trying to talk. So now below the list component, you see the outfit title and all of those, and the rest of the inlets that we defined with the tile, and this is just a randomly generated ID for that component. So now we're going to bind some data. So we start with this outfits data source. This is a GraphQL query that we can run. On the left, there's the parameters that this query takes, and then on the right is the data, and the functions will become very important here because we have to, as I mentioned, drill down to the data that we actually want to show. So we'll start with a constant function. The reason for this is we're just going to limit our results to 10 items. These could be any parameters, but for demo purposes, this will work. And then we're going to drop an iterator. This is going to iterate over the edges and give us a list of them, which in and of itself is not so fascinating. And then inside iterator, we have node. And we need to expand that, so we have this object function that we can drop that'll expand that node to a list of attributes. So here's the things that we can start to see the data we're actually going to use. The curator is the influencer, the person who created this outfit. The products is a collection that we're also going to expand with an iterator to drill down to the products that are in this outfit and also count. And yeah, let's continue. So we expand the curator object, and we will do the same with products and media. The first function does what you'd expect from a collection of media. So these would be our collection of images. We just take the first. So in this case, this media is the outfit image, and then this media inside the curator is the product, or sorry, the influencer. And we have a count function because we want to show a count of items in the outfit. And then over here now we're starting to drag the outputs of these functions into the view that we're actually binding. So the first we'll put the product count in there, and the influencer image URI, the outfit image URI, the title, and yeah. So, yeah, there's another thing in this video here. I think this is something we're going to work on, but for now, you have to give the image a width and height. Eventually, this will be coming from the device, and we'll be dynamically giving images the right size. I'll get into a bit more of that later. So now, I apologize as I've been talking about Android the whole time. We're looking at this on iPhone X or 10, depending on what you call it. So now we're going to launch that like lightweight demo app I mentioned and see the screen we built. And yeah, it's there. It's not, there's other options that we're not really showing here, like the ability for the list to be multi-column. Obviously, if you're building a real screen, it would not happen so quickly. You would be a lot more meticulous about padding and font sizes and colors and stuff. But the goal here is just to show how quickly you can go from a screen that you want to see on a device to actually seeing it on the device. And there was no app release here. So I like to joke that we kind of took all of the problems that we typically had to deal with in the mobile app and just shoved them all to the server, but it's like kind of true. So let's move to the presentation here. And I'll, okay, so yeah, I'll talk a bit about our future plans. First and foremost, the initial production rollout. I'll talk about that and the lessons learned. We're approaching a beta stage with this, and we're deliberately doing it kind of slowly because we want to get it right. Like if we can build one screen, we're pretty confident we can build lots of screens with this, but we need to make sure that the first couple are really solid. So we've been taking our time with that. And I showed you the home screen, which I said is partially dynamic. One of our near-term goals is after we're building this initial outfits catalog screen, we're going to focus on the home screen, which is a lot more complex, as you saw, with the images and carousels and so on. And along with that is algorithmically created screens. So on the web, we already have this. We have certain parts of the website are dynamically generated in a similar manner from a series of back-end services. And this was an initiative happening separate from ours, but once we saw that they were doing the same thing, now we're taking this engine that they're using and plugging it into ours. So hopefully in the future we could have screens that are maybe even tailored to individual users. Just really depends how far we take this. And yeah, I already mentioned Flutter and Jetpack Compose. I think it's a little too early for Jetpack Compose and our use of it, but I think it'd be really cool to try to build a Flutter client that could do what we saw, but strictly on from a single code base. And I guess I forgot to mention that part. We did React Native, and we suffered all the integration headaches. And when we saw Flutter, it was really cool, but we're like, yeah, but cross-platform integration. So yeah, it's in future plans, but that's why we didn't go Flutter initially. And also that was a year ago, and it was even earlier then. So in closing, I'd like to share some of the things that I've learned or relearned along the way. First and foremost, back to the production rollout thing, like the difference between a prototype that you can show in your weekly demo and a production-ready platform is immense. Like 80-20 rule, like all these things you've heard, and that's why I said lessons I've relearned. And also, don't cut corners. I worked somewhere previously, and one of the company values was paint both sides of the fence, and I think that sums it up pretty well. Like, you don't just make the part people see look nice. The whole thing needs to be like well thought out. And then this YPGNI is my own creation, so you've probably heard Yagni, you ain't gonna need it. This is you're probably gonna need it. And by that I mean clean architecture. You're thinking like, oh, this is a lot of boilerplate code, I'm just making a prototype. But your prototype is not just gonna be a prototype. Some manager or product owner is going to see that prototype and want it in the app, and you'll wish that you had just done it the right way to begin with. So yeah. This is something we were asking ourselves several times along the way, because a lot of what we were doing, like, why isn't anybody doing this? Is this crazy, or is it genius? Both? Like, we still don't know the answer to this question. I guess maybe some of the questions I get after this talk might fill me in on that. And then, yeah, a lot of the things that we learned doing React Native, as you can see, bled over into this solution. So we have Flexbox and Redux and a lot of those types of things. And this is the first project where I really did a lot of pair programming. I've done it in the past, but on this project we did some really big refactorings, and I could not have done it alone. The code review would have been just unbearable if somebody didn't participate in the refactoring and then was reviewing the code. So if you haven't done it, like, I really recommend it. You will learn so many shortcuts and other great things that you maybe hadn't even considered. Yeah, so that's it. The slides are here, and maybe I'm not supposed to share that because I think you're supposed to submit feedback before you see the slides. And yeah, we're hiring. So if you're interested, I think probably hiring in multiple locations, but primarily Berlin. So if you are interested in doing Android or iOS, or even we have a position for a release engineer. So if you're good with like Jenkins and CI and stuff, yeah. We have all that stuff up on our website. So yeah, I'll take some questions now.
Thank you very much, Andy.
Hi, thanks for your talk. I have a question. Have you considered Yoga Kit when you were choosing between Flexbox Layout engines, and why did you chosen the texture or Litho?
So Litho uses Yoga under the hood. I can't speak to texture. Not 100% sure about that, but yeah, Litho is using Yoga.
Hi, thanks. That's an interesting approach. How do you think you will handle situation when your client not supports some widget you just push to from server? For example, you decide to add to new screen some brand new like button or buy button, but your client not supported. Mm-hmm. Probably you could have some I don't know, capabilities system what your client actually support and configure server response by it, but there could be a lot of combinations. How will you handle it? And a second small question about what about animations?
Okay, so yeah, the first thing, we're already passing a library version header to the server. They're still building out all of the like management of that, but that furnace service I mentioned, like one of its jobs is to take the UI and data information from Compass and generate the query and persist that and version it and enforce. Also, we're enforcing like who can change screens, because obviously if anyone can go in and change a screen, that's chaos. So like the production environment's like super locked down and only certain people can change it. There will be like approval flow just like we have with code reviews and so on. So yeah, we've thought about that. It's definitely a hard problem. But if you think about it, when you're doing an app release, you're just kind of slowing the whole process down. Like, you still have the same problem. You're just dragging it out 3 weeks or 4 weeks at a time. So yeah, but we've considered that. That's definitely one of the risks with this, and we're going to really rely on that screenshot testing. And eventually, when we have more and more versions, yeah, we'll need lots of screenshot testing of the different versions. And another thing we can do, so another problem you can have with so much dynamic stuff is you don't want to become too flexible, like where you're tolerating things or just not showing things you don't support. So like we do what we expect, and if it doesn't work, we would rather crash and know about the problem than have the user be in some inconsistent state that we're not even aware of. So yeah, animations. We haven't really dug into that too much. So like creating this separate parallax layout I mentioned is like one way of kind of cheating, because you just build the animation into the component directly. I know Litho supports animations, so it really is just a matter of describing it in the layout response in some way that we can leverage that. Like actually the parallax view is a good example. We wanted to make certain parts of that configurable, so it would still be a parallax layout, but you would configure what percentage of the screen is the header taking, and how the ratio of the parallax, or the parallax factor itself. So yeah, if you can break it down into a bunch of parameters that you can pass to the rendering on the UI side, it should be possible. But yeah, the shared element transitions between screens, that'll be a little trickier, because then you have a relationship between screens.
Thank you, nice speech. And I have a question. You have two components on the screen. One of the components is button, and another some container. And this button should hide this container. And it is possible to make interaction like this.
Not currently with what we have, but there's also, I don't think, too many cases in our app where that happens at the moment. But I guess we could handle that the same way we did with like the standalone wishlist button. You could build a special component that has an X on it, and when you tap it, that component just knows to dismiss itself. It's a bunch of trade-offs. Like we thought about this with stateful button, like the wishlist button's an example. It's either in the wishlist or not in the wishlist. So you have two different graphical elements, and you have the tap that does the toggling of some state, and that we thought about how you could define that in a similar way to the way we built that outfit card component in reusable. But it was same situation. It's just easier to build a component that encapsulates that behavior while we figure out a good way to do it long term.
Thank you.
Cool, thanks.
And we have time for the last question. No. Yes.
You mentioned earlier on that you could do analytics and that sort of stuff, but it was driven by the server. Do you have callbacks and things like that from the client to trigger events as well that are then fired by the server, or how does that work? Yeah,
so I didn't go into a bunch of detail there. We already have something in the main app and some back-end services that do all our tracking. So we send a bunch of events to that, and then it in turn enriches them with contextual data. Tracking's its own topic, but yeah, basically we get information from Beetroot and the data response that tells us what to track, and then we fire events basically to the main app that does the tracking. I believe it's open source. We have something called Nakati that's like an event thing that's part of that, but that's server stuff.
Cool, thanks very much.
So I think that's it. I guess to wrap up, like a couple of things here. Like I guess my goal with this talk was to just share like some interesting ideas. Obviously, you probably won't run off and try to build exactly this. If you want to, come work with us. But yeah, I just thought it was an interesting combination of things, and I'd be interested in hearing everybody else's opinions on it in the next discussion. Yeah.